Golf, one of the most beautiful, challenging, and complicated sports in the world. The game of golf has been around for many years, with its popularity growing over the most recent few. Although the golf swing may look relatively simplistic, it utilizes multiple physics principles that contribute to the success of each shot. In order to achieve the perfect shot, a golfer must take many things into consideration, including centripetal force, velocity, attack angle, and launch angle. The first major physics principle that golf follows is known as the conservation of momentum, which states that the net or total initial momentum will equal the net final momentum of a system. Although this is only 100% true for isolated systems, the principle still applies to some degree in nature. When analyzing this golf swing, we can see two different systems come into motion. The first system is composed of my hands and the golf club, and the second, which comes into effect on the downswing, is composed of the golf club and the ball. The point of the backswing is to create as much potential energy as possible so we can convert it into kinetic energy. The key to the backswing is creating enough potential energy while still maintaining control of the club. By taking it back too far, you will gain more potential energy. However, it will be more difficult to control the club and you may struggle to get clean contact. Ideally, the golfer should aim to take the club back parallel to the ground in order to store as much potential energy while still controlling the swing on the way down. The wrists play a key role in the golf swing. When taking the club back, our wrists are cocked at an angle around 90 degrees. As the downswing begins, notice that my wrists slow down and extend to increase the angle, which results in the club speeding up. As my wrists slow down, the second part of the system must speed up to conserve the momentum. It is key to master this wrist movement in order to maximize the club's speed. As the ball is contacted by the club, the second system comes into play. An inelastic collision occurs where momentum is conserved but kinetic energy is lost. The ball is launched due to the impulse of the collision. Since momentum must be conserved and the ball having such a light mass compared to the club, the ball is launched at high speed to match the lost momentum of the club. The club loses momentum due to Newton's third law known as equal and opposite forces. The ball pushes back on the club with an equal force, causing it to lose momentum. Once the ball is hit, it follows the parabolic path of projectile motion. In order to hit the furthest shot, we must maximize the club's velocity in the x direction and find the ideal launch angle. Too much angle, and it will travel a short distance with a high peak, whereas too little angle will cause the ball to fly low and land much earlier than wanted. This can get you into trouble such as water hazards or cause it to lose distance due to friction on the ground. The golfer must choose the appropriate launch angle depending on the scenario of the shot. We can see the effect of launch angle in this upcoming picture, where I had a higher launch angle on the left and a lower launch angle on the right, causing the ball to peak at different heights. Now that we know some of the physics behind a golf swing, it is up to the golfer to decide what type of shot they want to hit. Whether it's a low shot, a high shot, or one that bends to the left or right, the shot they make will always rely on physics.